Okay, we're going to solve all these identities that you can see on the left hand side over here. So in order for us to do that, we first need to have some values. Okay. So in this situation, let's assign theta to this angle, and we have 3, 4, and 5. Okay, so let's identify some things we need. Well, in order to prove all these identities for the purpose of this video, we're going to assign sine of theta. Sine we know is opposite over adjacent. So in this case, I can find my opposite by looking at this 4. That's opposite theta. So we can then say, well, sine is going to be 4 over 5. I can do the same for cosine theta, where I say the cosine of theta is equal to 3 over 5, since it's my adjacent over my hypotenuse. And then we have tangent of theta, which is going to be opposite over adjacent. Okay, so this is the base values I'm going to use in order to prove all these identities. So let's look at the first one. Okay, so the first one tells us, well, tangent theta is equal to sine theta over cosine theta. Well, to prove this one, I'm going to use values. Well, I know sine theta is equal to 4 over 3, so let's substitute what we have. Okay. Sine of theta is 4 over 5, while cosine theta is 3 over 5. Now I can multiply both top and bottom with the reciprocal, since I don't want a fraction as a denominator. So let's multiply it with the 5 over 3 on both top and bottom. Well, we can now see that this 3 cancels that 3, this 3 cancels, this 5 cancels this 5, which then we're left with 1. So at the bottom of the fraction we have 1. This 5 cancels this 5, and I have 4 multiply 1 over 5 over 3 multiply 1. So in that case, I can then see, well, 4 over 3 is in fact equal to 4 over 3. So we know this identity works. Okay, let's look at the next one. So the next one tells us that sine squared theta plus cosine squared theta, let's write that down, sine squared theta plus cosine squared theta is equal to 1. Now in this case, I'm just going to simply again use direct substitution. So we have 5 over 4 squared plus cosine being 3 over 5 squared is equal to 1. Following exponential rules, I know that my exponent needs to multiply with both my numerator and my denominator. Okay? So in this case, we're going to have 4 squared, which is 16, over 5 squared, which is 25, plus 9, or 3 squared, which is 9 over 25. So that should be equal to 1. Now I have 16 plus 9, which is 25, over 25, which is 1. And therefore 25 can go into 25 one time. So 1 is in fact equal to 1. So we know this identity is true as well if we test it with some values. Okay, let's look at the third one. So the third one, let's skip the third. Okay, I'm just going to do it in this order that's presented here on the left. So this one tells me that sine 2 theta is equal to 2 sine theta cosine theta. Okay, now for this particular situation, I'm going to assign a value. Well, let's look at this triangle. Let's say our special triangle, 60, 30. Across from 60 is the square root of 3. Across from 30 is 1, and my hypotenuse is 2. So what I'm going to do here is I'm going to select the sine of 60 and the cosine of 60. Okay. So sine of 60 is my opposite over my hypotenuse. which is square root 3 over 2. And cosine 60 is opposite or adjacent over hypotenuse, which is 1 over 2. So this is why I added these rules at the top here. So we can rewrite for 2 theta. This just means that two angles, we're working with the same angle. So in this case, it's going to be A plus A, which gives me 2A. But instead of using A, we're just using theta now. Okay? So let's rewrite. Let's look at this formula. So it tells us that the sine of theta times the cosine of theta plus the sine of theta times the cosine of theta is then equal to 2 sine theta cosine theta. So let's see what this tells us. So now I can replace sine of theta. I'm going to say, well, in this case, I'm going to set theta equal to 60 degrees. Just so we can make sense of what's happening over here. So theta is equal to 60. So let's substitute what we have. The sine of 60 is square root 3 over 2. And we need to multiply this with 1 over 2. And we need to plus this with square root. Actually, these two are supposed to be flipped around. My apologies. So it's supposed to be, let me quickly flip it around. Cosine of theta, sine of theta. So it's going to be 1 over 2 times square root of 3 over 2. And now let's substitute what we have in this side. In this side we have sine, which is square root 3 over 2 times 1 over 2. Going down we can see. Now let's substitute using x. Let's use x substitution, okay? So we can then say, well, x plus x is 2x, and in this case x 2x. Since we can say x is equal to 3 over 2 times 1 over 2. Okay? But let's say for argument's sake we didn't use that. Let's say we didn't use this. So let's do the equation then. Here we have square root of 3 times 1 is square root 3 over 4. Okay, look. 2 times 2 is 4. Plus square root of 3 over 4 should be equal to 2 square root 3 over 4. If we go down to simplify this one, we can say, well, 3 plus 3, that's going to give me 2 square root 3 over 4 is in fact equal to 2 square root 3 over 4. But we can simplify this by saying subtract, or divide both sides by 2. Divide by 2 since we have 2 of the same. So we can then say, well, square root 3 over 2 is in fact equal to square root 3 over 2. Okay, so this identity works out as well. Clear the board quick. Let's look at the next one. The next one tells us secant of theta is equal to 1 over cosine theta. Okay, so secant theta is equal to 1 over cosine theta. By definition, we know that secant is the reciprocal of cosine. This means secant is equal to the hypotenuse over my adjacent side. Okay, so let's write that down. My hypotenuse is 5. My adjacent side to theta is 3. So we have 5 over 3. This should be equal to 1 over 3 over 5. Since I'm going to substitute cosine with 3 over 5. Okay. If this is the case, well, we can multiply with the reciprocal at the bottom of the fraction again. Where we have 5 over 3 times 5 over 3. Cancel, 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 cancel. We're left with a 1. And then we have, in fact, 5 over 3 is equal to 5 over 3. So this one works out too. Okay, next one. We have cosecant. So in this case, we have cosecant theta is equal to 1 over sine theta. We know by definition that cosecant is the reciprocal of sine, meaning if sine is opposite over hypotenuse, cosecant will be hypotenuse over opposite. So let's write that down. Cosecant is the hypotenuse over my opposite side. Well, in this case, I have my opposite side, which is 4. So that needs to be at the bottom. So we have 5 over 4 should be equal to 1 over sine, which is 4 over 5. 4 over 5. Now again, we're going to multiply with the reciprocal. So multiply 5 over 4. And this equal sign, as I always mention, you can think of it as a mirror. Whatever you do on the bottom of the fraction, you have to reciprocate to the top of the fraction. Okay? This one cancels, cancels, cancels. We're left with 5 over 4 is in fact equal to 5 over 4. Okay, next one, cotangent. So we have cotangent theta is equal to 1 over the tan of theta. Well, by definition, cotangent is the reciprocal of tangent. So tangent, in this case, is 4 over 3. So cotangent will be 3 over 4. So we have 1 over, and you can sort of see what's happening. You should be able to see the pattern now. But if you don't, that's okay. Again, we're just multiplying with the reciprocal. So cancel, 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 cancel. We're left with 3 over 4, which is in fact equal to 3 over 4. Okay, now we get to some more Pythagorean identities. We have 1 plus tan squared of theta should be equal to secant squared theta. Okay. Let's rewrite secant square as, you can now just look at this one where you have 1 over cosine, but for the video I will rewrite it as 1 over cosine. Okay, so let's substitute what we have. Let me just quickly write this one. I'm going to rewrite secant as 1 over cosine theta, or cosine squared theta. Okay, actually no. What we're going to do in this case is we're going to look at the definition of secant, which is cosine. So in this case, we're going to take the hypotenuse and we're going to place this one over the adjacent side. Okay, I'm going to just make it very simple. So let me erase this part. Let's go again. So 1 tangent, let's substitute tangent with what we have. So tangent is 4 over 3 and we need to square it, and this should be equal to secant squared, which is the hypotenuse over the adjacent side. So the hypotenuse is 5, the adjacent is 3. We're going to square this. So now we have 1 plus 16 over 9 should be equal to 25 over 9. If we solve a very simple fraction equation where we add whole numbers with fractions, we know that we need to turn this one to have the same numerator and same denominator. Okay, so 1 is equal to 9 over 9. So I can then say 9 plus 16, which is 25 over 9. So therefore 25 over 9 is in fact equal to 25 over 9. So this identity definitely works. Now we have 1 plus cotangent squared theta should be equal to cosecant square theta. Okay, so we know the definition of, or maybe we don't know, but the definition of cotangent is the reciprocal of tan, which I mentioned before. So if tan is 4 over 3, cotangent is simply 3 over 4 squared. 1 plus 3 over 4 squared. Then we have the definition of cosecant, which is the opposite of sine. So in this case, if sine is 4 over 5, then this one should be 5 over 4 squared. Exactly the similar, or exactly the same as the previous one. So we have 9 over 16 should be equal to 25 over 16. We can change one. We can change it to 25 over 25. Oh, what am I doing, man? Excuse me. 16 over 16. 16 over 16. So in this case, we have 16 plus 9, which is 25 over 16, is in fact equal to 25 over 16. Okay. Let's get the next one. Only 3 more to go. Let's go. Okay. So this one tells us, well, cosine 2 theta is equal to cosine squared theta minus sine squared theta. First things first, let's look at what we can use. We can use cosine, where it's cosine x times cosine y minus sine x times sine y. So when we have, so in this case, let's rewrite this one to make a better sense of it. So cosine, this would be theta plus theta. Okay, theta plus theta is 2 theta. So let's use 60 again. Okay, cosine 60. So cosine 60, if I go back to this one, we have cosine 60, which is 1 over 2. So let's write that down again. Cosine 60 is equal to 1 over 2. While sine of 60 is equal to square root 3 over 2. So let's substitute what we have. Well, on the left hand side, I'm going to say cosine theta, so let's do it, cosine theta times cosine theta minus sine squared theta minus sine of theta times sine of theta. Now, we can already see that cosine theta times cosine theta can give me cosine squared theta. But let's ignore that. Let's ignore that. Okay, so let's substitute what we got. We got 1 over 2 times 1 over 2 minus square root 3 over 2 times square root 3 over 2 cosine squared theta. This is going to give me 1 over 2 squared minus square root 3 over 2 squared. So in this case, I have 1 over 4 minus this is going to be square root 3 times square root 3 is square root 9, so that's going to give me 3 over 2. On this side, I have 1 over 4 minus the same thing, 3 over 2. And we can already see they're identical, right? We can already see this. Let's just proceed anyway. So, in this case, we want to use a common lowest common multiple. So, I can multiply both top and bottom by 2. This is then going to give me 6 over 4. So, we have 1 over 4 minus 6 over 4. So in this case, it's going to be negative 5 over 4 is in fact equal to negative 5 over 4. Now, ideally, you could have seen that at this stage, the identity is already well in its way to being proven, right? It's already established. It's just a different form of writing it. Okay, but it's very important to make these connections, because sometimes they give you these questions where you have to rearrange. You have to rearrange for certain identities to solve them. So they could do something like, let's say we have cosine 2 theta, then we have, let's say, some random 4 is equal to sine squared theta 4, and then, yeah. Actually, that's an extremely easy example, but anyway, nonetheless, let's continue. So now we have tan of theta, sine of theta, plus cosine of theta, and we need to rewrite this as 1 over cosine theta. Okay, so earlier we learned that tan of theta can be rewritten as sine of theta over cosine of theta times sine of theta plus cosine of theta over 1 over cosine theta. Okay, before I can add these two fractions together, I need a common denominator. In this case, my common denominator could be cosine theta. How do I do that? I multiply this one with both top and bottom with cosine theta. Okay, so now sine times sine is sine squared theta plus cosine times cosine is cosine squared theta. Should be equal to 1 over cosine theta. Well, in this case, we have sine squared theta plus cosine squared theta, which we know through our Pythagorean identity theorem that Pythagorean identity, is 1 over cosine theta, because this one changes to a 1. We've proven that earlier. So then we have 1 over cosine theta. So this in fact is true. Okay? That tangent theta times sine theta plus cosine theta is equal to 1 over cosine theta. Okay, not bad, not bad. Then we have this final one, where we have tan 2 theta is equal to 2 tan theta over 1 minus tan squared theta. Okay, in this case, let's pay attention to our special triangle on the right hand side, 45, 45, 90. Okay, it's a little special triangle. So I'm going to use the tan of 45. So let's set the tan, let's set theta. So set theta equal to tan 45. Oh, let's set theta equal to 45, excuse me. So therefore theta is, tan of theta is in fact equal to 1, since it's my opposite over my adjacent. We're going to use 1. But in this case, let's first do it. Let's expand this sine 2 theta. This again just means theta plus theta. So let's focus on this little formula here on the right hand side. We have the tan of theta, but in this case let's use the tan of 45. Okay, so let's say the tan of 45 plus the tan of 45 over 1 minus tan of 45 times tan of 45, and this should be equal to 2 tan of 45 over 1 minus tan of tan squared, or tan 45 squared. Okay, let's substitute what we got. We know that the tan of 45 is 1 based on a special triangle. So we have 1 plus 1 over 1 minus 1 times 1. Even, yeah, never mind. Oh, maybe a little bit of a bad example, since this one's going to be undefined. Doesn't really matter. Okay, so look how identical they are. 2 over 0 and 2 over 0. Now, this is undefined, right? But I just wanted to use some values to talk about these identities, or at least an introduction to all these identities, just so you can get familiar with them before you start practicing some real questions. Okay, but yeah, at this point we can already see that, well, let's have a look. The tan of 45, the tan of 45, so tan squared 45. Okay, and then over here we can see tan of 45 plus tan of 45, which is in fact equal to 2 tan 45, because there's 2 of them, right? So 1 plus 1 in this case, and in this case we have 2 times 1. Okay, So yeah, these were the basic bit of identities. Yeah, hopefully you could follow, and I'll make another video on where we add some more complicated or complex equations. Okay, boy.